Let's take a look at one of our C-17s now.
Hello, I'm Major Aaron Port, an instructor pilot with the 89th Airlift Squadron.
I'm Tech Sergeant Trevor Dixon. I'm a mission load master here with the 89th Airlift Squadron.
We're here today to give you a tour of this C-17 Globemaster III from the 445th Airlift Wing at Wright-Patterson Air Force Base, Ohio. If you'll come with me, we'll start to take a tour of the outside. As you can see, the C-17 is a large aircraft. It's a 170-foot wingspan, 170-foot long, and 55 feet tall at the tail. Our maximum takeoff and landing weight is 585,000 pounds. We can carry over 150,000 pounds of mixed pallets, cargo, and passengers. So as you can see, the C-17 is powered by 4 Pratt & Whitney high bypass turbofans, each producing 40,400 pounds of thrust at sea level. Another notable feature of the C-17 is the high wing. Unlike airliners that have their wings and engines low to the ground, the C-17 has our engines elevated as high as possible so that if we're going into an austere location or a dirt runway, we have a smaller chance of sucking up any debris into the engines. You'll also notice the C-17 has winglets at the end of the wings. That's a key identifying feature for the C-17. If you see a big gray plane flying around, it doesn't have winglets, it's a C-5. If it has winglets, that's a C-17. Behind me, you'll see the main landing gear underneath the aircraft there. We have a rather unique configuration of wheels. It's called triple tandem. So on each side, there are 2 sets of 3 landing gear in front of each other. When we retract the landing gear, in order to save space, they actually come up and rotate 90 degrees to fit within the fuselage. Behind that, you can see the ramp extended down onto the ground there. You can see there's really not a whole lot of ground clearance under the aircraft itself. It's designed to sit low to the ground to make loading easier. So we have the ramp down there and what are called ramp tows, which Sergeant Dixon will tell you more about. That'll allow us to easily drive vehicles and equipment onto the aircraft. We can't see it very well, but as you look up, there's a ramp that ends about halfway up the opening there. The cargo door will actually go up while the ramp comes down, giving us a larger opening to load even larger cargo onto the aircraft. Now that I've given you some idea of what the exterior features and design of the C-17 are, we'll continue our tour and head inside. And welcome to the flight deck of the C-17. Unlike many older aircraft, the C-17 only requires a crew of 2 pilots, the pilot and the co-pilot, to fly the aircraft. There's enough computer assistance that we don't need a navigator or a flight engineer. What that does mean is a lot more workload for us sometimes, but we have a lot of training to help us get through it. The C-17 is the most modern mobility aircraft employed by AMC. We have fly-by-wire flight controls and heads-up displays that allow us to perform our mission even in bad weather. We are night vision capable. We can ingress at low altitude down to 300 feet AGL or perform a high altitude ingress at altitudes up to 42,000 feet. Max airspeed for the C-17 is 350 knots. Usually we cruise around 310 knots at 35,000 feet. It's very similar to where commercial airliners fly. We have 4 turbofan engines producing 40,400 pounds of thrust each for a total of 160,000 pounds of thrust. Max aircraft weight for the C-17 for takeoff and landing is 585,000 pounds. We can land on assault strips that are unpaved with dirt down to only 3,500 feet long and then take off again. We're designed to handle an M1 Abrams main battle tank or 18 pallets of cargo and any number of other outsized cargo that might be required. I'm an instructor pilot here at the 445th Airlift Wing. That means that I'm in charge of both taking new pilots direct from pilot training and letting them work their way up from a co-pilot to an aircraft commander and eventually to upgrade to instructor as well as teaching any pilots that have lapsed in their currency due to maybe medical issues or civilian commitments. It's our job to bring them back up to speed and make sure that they're fully mission qualified. We fly for the Air Force Reserve Command as they need to move troops and supplies around the United States in support of exercises and training, as well as flying real-world missions for Air Mobility Command across the globe. We have regularly scheduled missions that bring us to Europe, the Middle East, and the Pacific. And then we also fly on-demand missions to AMC basically anywhere in the world. We fly with or without aerial refueling. Usually our range is about an 8 to 9 hour flight unrefueled. That will easily get us across the United States or the Atlantic Ocean, or about halfway across the Pacific, say California to Hawaii, without needing refueling. With refueling, our range is basically unlimited. As I said before, our basic crew is only 2 pilots. However, if we have a long day, we bring at least 1 extra pilot and loadmaster with us so that while 2 pilots are flying, we can have a 3rd pilot resting, and that lets us fly for as long as a 24-hour day with 3 pilots. And now let's go ahead and take a look at some of the instruments that let us fly. So this seat is the pilot seat on the left-hand side. It can be flown from either seat. The controls are basically identical, but we'll start out here. This is the stick. Like I said, it is a fly-by-wire stick, but it's got very much traditional feel to move forward, backward, left, and right. The other primary controls, the throttles here. 4 throttles, 1 for each engine. We also have controls for the flaps and a couple other flight control issues right in the center. Along the front of the glare shield, we have a lot of different configurable displays, known as multifunction displays, because we can choose what information to display based on the needs of the moment. Along the center console here, we have what we call mission computers. They let us tell the aircraft where and how we're planning on flying so that it can do the math and calculations behind the scenes to tell us things like how much fuel we're going to burn for a flight, how long it will take us to get to a certain point, and what speeds we need to take off and land at a certain airfield. We have additional controls to control what we display on the maps and such. We also have controls for our defensive systems, for opening the doors, and a couple miscellaneous controls. Above the glare shield, we have heads-up displays for the pilot and the co-pilot. Those give us the ability to look outside the aircraft but still monitor our instrumentation, the flight path, speed, altitude. They give us a lot better situational awareness, especially when we're doing tactical operations, low-level flying, or in bad weather conditions. Our communication panels sit up front as well. They allow us to easily control the 7 different radios that we have access to. In the center of the glare shield is the auto flight control panel, or the autopilot. That's where we can select our altitudes, airspeeds, headings, etc., so that our autopilot can help us maintain our flight plan with excellent accuracy. The autopilot allows us to fly for long periods of time without the associated fatigue of hand flying. It also does an excellent job of maintaining courses and altitudes better than even the most proficient pilots can. Up above on the overhead panel, there are a lot of additional controls for various systems across the aircraft. Flight controls, the electrical system, the fuel system. It also has our central warning and annunciation panel. It can tell us what any errors that go on with the aircraft. It will tell us what it is, so we can reference this panel and then go into our checklist and correct any problems that might arise during the flight. It looks very complicated, but I promise we all know what all the buttons do. Along the glare shield here, we have a total of 4 multifunction displays. These let us display different data depending on our needs during the flight. Here I have our main navigation display. It will display our current location, our flight plan, radar or terrain as necessary, nearby airports or navigational aids, so that we can have good situational awareness on what's going around around the aircraft. This display here is currently showing our primary flight display. This is a combination of a lot of traditional instruments that allows us to look in one place and get an excellent understanding of what the aircraft is doing. Along this side, we have our airspeed in knots, indicated airspeed. We have the altitude above sea level, and we have our current compass heading. The large central area is called an attitude directional indicator. So that tells us what our pitch is, nose up. So as you start pulling the nose up, 5 degrees, 10 degrees, nose high. It will also tell us how much bank we're in as you start rolling left or to the right, and helps us to maintain controlled level flight even if we can't see the horizon or the ground outside because it's either night or we're flying through clouds. Further along, we have several pages of engine instrumentation telling us things like how fast the engines are turning, how hot the exhaust is, fuel pressure, temperatures, and so forth. This is the crew rest area, where on long missions we can have up to 2 crew members sleeping and allowing us to extend our duty day so that we can fly across the oceans and make it to destinations further away than if we had to stop and spend the night. So we have 2 bunks here, and then additionally there are 2 other seats for crew members that might be required, or if we're bringing additional ground personnel like crew chiefs to help us when we get to our destinations. This is also where the stairs come up onto the flight deck, so it can be a little noisy, but it's definitely better than sleeping in the back.